Welcome. We are doing Module 10 Homework 3. Module 10 Homework 3 really has two different names. You could say we are graphing linear inequalities, or you could say we are solving linear inequalities. They're both really saying the same thing. So we're going to be following these steps here. I'm not going to go through these steps one by one here. I'm just going to show you how it works. But I'm just going to scroll through these slowly for a moment. So these are the steps we're going to go through. So let's look at some examples. We're going to graph this, or another way to say that is solve this. Now, I'm going to show you the easiest way to understand it. And at the end, I'm going to explain to you the meaning behind all of this. Why we're doing what we're actually doing. But here's how you do it. First step, you pretend it's an equation. So act like it's an equation. Now, it's not really an equation. It's an inequality. So we'll certainly have to do more than just a pretending step. So since it's an equation, since it's y equals mx plus b, we know it's a line. We can graph the line. There's various ways to graph the line. One way to graph the line would just be to make a table of values. If I plug in 1, I get 5. If I plug in 2, I get 7. So 1, 5, 2, 7. Draw the line that connects them. You want to be a little more careful than I'm being here. It'd be good if you had some kind of straight edge to draw it with, but this is good enough for our purposes. So you draw the line that connects them. The next thing you do is you pick any, well, let me say this a different way. Notice that there's a bottom part of the graph now, and there's also a top part. You might also call that the left part and the right part. So what you want to do is pick any random point, either from the left or from the right. The key thing is, do not pick a point close to the line. You want to pick a point far enough away that even if you were a little bit sloppy with drawing your line, you're sure that point is not on the line. So I'm going to pick the point right here at 3, 2, and that's just a randomly chosen point. Then what you're going to do is you're going to take the point you picked, you're going to plug it into the inequality, the thing that we're actually trying to solve. Now be careful. Be sure you plug the x coordinate in for x and the y coordinate in for y. Let me change this. I'm going to make the x coordinate green. I'm going to make the y coordinate blue. So I'm going to copy down my equation. I have y is greater than or equal to 2x plus 3. I'm going to take the x in the equation. I'm going to make that green. I'm going to take the y in that equation and make that blue, kind of matching what I did before. So the x needs to go in place of the x. So I'll replace the x with 3. The y needs to go in place of the y. So I will replace the y with 2. And then we see if this is true or not. I end up with 2 is greater than or equal to. If I do that calculation, I get 9, and that's false. Okay. Here's what happens if you get an answer of false. If you get an answer of false, that means this point is not part of our answer, and the entire half of the graph it came from is not part of our answer, and that means our answer is everything on this side. So when it's false, you shade in the other side. So the final answer to this question, which is a graph, is every point that is on the line and also every point that is on the left side of the line. That is the final answer. Okay, let me erase some of this. I need to erase a lot of things. So one moment, please. Okay, now we're going to do the next one. How do you do it? You need to draw the graph. So let's draw the graph. I'm going to take this equation. I'm going to solve it for y. Oh, sorry. First of all, I need to treat it as if it is an equation. So we're writing it as an equation, even though it's an inequality. This is just a temporary thing. I'm going to solve it for y. So I will add 2x to both sides. I get y equals 2x plus 6. And then I'm going to divide both sides by 3. I get y equals 2x plus 6 over 3. And that's the same as saying y equals 2x over 3, or 2/3 x, and 6 over 3, or 2. Well, luckily, my y-intercept is a whole number, so that's easy to plot. And then I can use the fact that this is the slope to tell me that there's a rise of 2 and a run of 3. And I can go 2 units up and 1 up. One moment. And 1, 2, 3 units over. And there is another point on my graph. And now I can connect the dots. Again, it's a little bit hard on the computer screen to do this very carefully, but you want to get a good, solid graph when you actually do this. A nice, carefully drawn graph when you do this. So let's say that's the graph of our line. Okay, that's the first step. Now, before we go to the next step, notice on the previous equation I had greater than or equal to. There is an equals part of that. Notice on this problem I have less than, but I do not have an equals on it. When you do not have an equals, you do not actually draw the solid line itself. What you do is you make it a dotted line. And I'm going to explain later on why that makes sense that it would be a dotted line. But the rule is, if you have an equals on it, solid line. If you don't have an equals, like on this problem, dotted line. Then you do the same as before. You pick a random point, and you want to make sure your point is not on the actual line itself. So you want to make sure you're clearly off the line. I like to pick the point 0, 0 because it's easy to deal with, but I'm not going to do that because I just want to be super careful and make sure that the point I'm picking is far away from the line and clearly not on it. So I think I'll pick this time this point right down here. That's the point 5, 1. Now you take your point and you plug it into your inequality. So we're going to plug that into this. Be sure you plug the x in for x and the y in for y. So we have 3, and in place of the y, we're going to put our y coordinate of 1, minus 2. In place of the x, we're going to put our x coordinate of 5. And the question is that less than 6? That gives me 3 minus 10 is less than 6. That gives me negative 7 is less than 6, and that is true. Okay, remember what happened last time. Last time we got false, and so we eliminated the side of the line that the point was on. This time we got true. If you get true, that means this point is part of your answer, but it also means that everything on that side of the line is part of the answer. And so our answer is the dotted line along with everything to the right of the line. Or if you want, think of it as everything below the line. That is our answer. So if it's true, shade in that side. If it's false, shade in the other side. So the final answer to this one is the dotted line and everything to the right of it also. Okay, let's erase this and move on to our next one. So the next one, there's more than one way to think about it, but I'm going to kind of just follow what I've been doing. So step one, pretend it's an equation and graph that. Well, I hope you remember the graph of a line where the equation is x equals a number is just a vertical line at that number. Now, since we have greater than, we're not going to draw a solid line. We're going to draw, I don't know why my computer is acting like this, but we're not going to draw a solid line. We're going to draw a dotted line. If it had been x is greater than or equal to 2, then we would have drawn a solid line. But since it's just greater than, we're going to draw a dotted line. So a vertical line at 2, but a dotted vertical line. And then we do the same as before. We pick any point we want, but it needs to be clearly not touching the line. So I'm just going to go over here to the right again. I'll pick the point 6, 3. I hope the next step is not confusing, but now we go back to our inequality and we plug the numbers into our inequality. Our inequality does not have any y's in it, so we don't care about the y in this case. The only thing it has is an x in it, so we're going to plug 6 in for x. So we take our inequality, x is greater than 2, get rid of the x, and replace it with our x coordinate of 6. And then we ask ourselves, is this true? Yes, 6 is greater than 2. That is true. So just like the last time, since our point makes it true, that means our point is part of the answer, and everything on the same side of the line with that point is part of the answer. And so our final answer is the dotted line and everything shaded to the right of the dotted line. Now, that kind of makes sense, I hope, because here's what the question's asking. It says, where are all the x coordinates bigger than 2? And it's everything to the right of 2. Okay, let's erase this, and we will do the last one, and then we'll talk a little bit about what in the world this means, or why hopefully what we're doing kind of makes sense. Okay, now we're going to graph this one. So, of course, we start by pretending it's an equation, and then we need to somehow graph the equation. Now, there's various ways to do it. One way to do it would be this. I am going to solve it for y, so I will subtract x from both sides, getting negative 2y equals negative x plus 8. Then I'll divide both sides by negative 2. When I do that, on the left I have y. This is 1/2 x, and this is minus 4. And I could graph it by plotting the y-intercept of negative 4, and then using rise over run as the slope, and get the line. There's nothing wrong with that, but I want to show you a different way to do this. This could be helpful sometimes. Let's do a little bit more erasing, and then I will show you. Since we have an x with no coefficient on the x, I am, instead of solving for y, I'm going to solve for x. So I will add 2y to both sides. That's going to give me x equals 2y plus 8. Since I've solved it for x, if I make a table, it'll be easy to make rows in the table by, instead of the usual way, plugging numbers in for y. So I'm going to do that. Now, I'm going to plug in 1 for y, but you're going to see in a moment why that's a bad idea. When I plug in 1 for y, I'm going to get x equals 2 times 1 plus 8. So x equals 10. And you may say, what's wrong with that? But when I try to plot the point 10, 1, because of what I put here, there's no place for me to plot it because we don't see where 10 is. So if we had more graph, there's nothing wrong with that. But that's not going to be terribly helpful. So I'm going to plug in 0 for y. When I do that, when I plug in 0 for y, I'm going to get x equals 2 times 0 plus 8. So x equals 8. And I can certainly plot the point 8, 0. So in this case, I'm going to need to plug in some negative numbers for y. So let me plug in -1 for y. When I plug -1 into that, I get x equals 2 times -1 plus 8. So x equals 6. So there's my other point, 6, -1. And now that I have my 2 points, I can draw the graph. Now we need to decide, is it going to be a solid line or a dotted line? Well, that depends on this right here. I'm hoping you remember the rule. Since I have less than or equal to, that's when you have a solid line. So I'll connect the dots with a solid line. Please do this carefully when you're doing it yourself. I'm just going to be a little bit sloppy on that. Now we need to pick a point. What point do we pick? Any point we want that is clearly not touching the line. Well, I can see that my favorite point 0, 0 is far enough away from the line that it's clearly not touching it. So I'm going to use 0, 0. So we need to test 0, 0 and see if it makes this true. Before we do that, if it does make it true, then we include this point because it makes it true, and we include every point on the side of that line. If it made it false, then we would shade the other side. So let's see what we actually get. We're going to plug 0, 0 into that. We're going to get 0 minus 2 times 0 is less than or equal to 8. That 0 minus 0 is less than or equal to 8. And that is 0 is less than or equal to 8, and that's true. Because it makes it true, we include the point that's true, and we include all the points that are on that side. So our final answer is that solid line and all the points that are to the left of it or above it, however you want to look at it. Okay. If you don't want to watch the rest of this, you really do not have to. So it's totally your choice as to whether you want to watch it or not. But here is what's really going on. Let me just do a little quicker erasing here. Here is what's going on for this problem and for all the other ones here. We said for this problem that the answer is the solid line and everything else that's above it. That's what our answer is. So what does that mean that that's the answer? Well, that means that every single point in this yellow area makes the inequality true. For example, I'm just going to pick a random point here. Look at the point 1, 3. Does 1, 3 make it true? Well, let's see. If I plug 1 in for x and 3 in for y, I get 1 minus 6 is less than or equal to 8, and that's true. Let's pick another random point from that section. How about the point -2, -2? Every single point in the yellow area is supposed to work. If I plug in -2, -2, I get -2 minus 2 times -2 is less than or equal to 8. And that's -2 plus 4 is less than or equal to 8. and that gives me 2 is less than or equal to 8, and that's true. No matter what point I pick in this yellow area, it is absolutely going to work. Now, let's pick a point on the line. Let's just pick one of the ones that we know for sure is on it. We know that 6, -1 is on it. But pick any point at all that we know for sure is on the line. Let's plug that in and see what we get. If we plug 6, 6, -1, be careful, 6 for x, -1 for y, we get 6 minus 2 times -1 is less than or equal to 8. We get 6 plus 2 is less than or equal to 8. That gives me 8 is less than or equal to 8, and that is true. So also all the points on the line work. Now notice these are actually equal to each other. Every single point, excuse me, that is on the line will make the left and the right equal, and since there was an equal on the inequality, that's why they make it true. Now imagine the original inequality was this. Imagine it did not have the equals on it, that was missing. Well, then the point we just picked would have given us 8 is less than 8, and that's false. And so the points on the line wouldn't work. That's why you make it a dotted line when you have less than or greater than without the equals on it. And then lastly, all the points in the bottom here aren't supposed to work. If you pick any random point there, you'll see it doesn't work. For instance, here's the point here, which is the point 9, -1. The ones that are not in the shaded area are not supposed to work. Let's plug that into our inequality. Let's see if I can erase some stuff quickly to make some room for that. So let's plug them into our inequality. So we're going to plug 9 in for x. We're going to plug -1 in for y. And we get 9 plus 2 is less than or equal to 8. We get 11 is less than or equal to 8. And that's false. And it should be false because these are not part of our answer. So the ones in the yellow area, every point there works. The ones on the solid line, every point there works. That's why that's our answer. Okay, that is the end of Module 10, Homework 3.